Okay, here's a quick video on introducing buffers and looking at how they work. So just to start off with, what a buffer is a system that can resist a change in pH. You can identify a buffer system because it's going to be a weak acid with a weak base, and they're each other's conjugates, meaning that they just differ by one hydrogen. And if we're looking at page 8 and 9 of your data booklet, they are right beside each other on a table. So butanoic acid with its base ion would make a buffer. Same thing with the next two, and so on as we move down. So as long as you're right beside each other, that difference of one hydrogen, you can make a buffer system. Again, as long as it's both weak. So using butanoic acid as an example, we can show how the buffer system works, being able to resist that change of pH if small amounts of a strong acid or a strong base was added. So for this one here, butanoic acid, from column 2, you know that we have the acid, and from column 3, you know you have the base, and then there's a Ka value, but that doesn't really matter for us here. So what happens if you added in the hydronium ion? Because the hydronium ion is an acid, it would react with the base part of the conjugate system, because both of these would be present. So if we wanted to show that reacting, we have H3,7COO negative, and because it's a strong acid, our arrow would just go in one direction, meaning it's not in equilibrium, and we can show that the hydrogen from the hydronium is going to come over to the base and form water, and C3H7COOH. So essentially, the base part of the buffer can neutralize that small amount of acid that's being added to the system. So that's how it would work if we had the hydronium added. What would work, or how it would work, if you added the hydroxide instead of being added to the base part of the buffer system, it would react with the acid part of the buffer system. So we can still show that by taking the acid and the OH ion, because it's strong, again, same idea, our arrow would just go in one direction, not in equilibrium, and then the H from the COOH, that is the acidic acid, will come over to the OH ion, forming water, and C3, oh, this should have been an H, sorry, C3H7COO negative. So it is neutralizing the base that's being added in. As long as it's small amounts, the buffer system can maintain that pH. I hope you found this helpful. If you did, please subscribe. Oh, I forgot this slide. And one more slide. If we are looking at the buffer region on a graph, so just showing it on a graph with a titration, we know we're adding to a pretty weak acid here, and we have a weak base. We're not quite hitting 14 when the titration's over. So the part that would show that resisting of that spike in pH is where that graph kind of is horizontal for a little bit. So if I looked at this graph and I wanted to identify the buffer region, it's just that area where we can resist that change in pH until it can't anymore, and that's when you see that jump and that titration would be over. Okay, now if you found this helpful, please subscribe, and if there's any other video I can do for you, just let me know. Thanks for watching.